All right, welcome back. In this video, we're going to talk about circular geometry. We're going to talk about two specific concepts, inscribed and central angles. I have a question here. By the end of this video, you will know the relationship between inscribed angle and central angle and how we can solve questions like this. We have this diagram. We want to find angle A, which is right here. We want to find angle 2, which is the entire angle there that it completely touches this chord and this chord, and angle 3, which is right here. All right, let's get into that in no particular order. All right, we're going to go through and basically fill all of the interior angles, as many as we possibly can based on the information we have. Now notice that this tick marks on each of these chords means that these length of these chords, they are all the same. That's what it means. We have this angle here 60 degrees and we don't have anything else. All right, first thing first, we know that this side and this side, they're equal to each other. They're both radii, right, of the same circle. That means that this angle must be 60 degrees because this is isosceles triangle. All right, and it's one of the properties of isosceles triangle. So now that we have these two angles, we can easily go through and get the third angle, and according to the famous theorem of for the sum of the angle in a triangle must add up to 180 degrees, we know that this angle must equal to 60 degrees as well, because 60 plus 60 plus 60, that's equal to 180 degrees. So we have that angle as 60 degrees. Now, we need to find angle 3. Now, I need you to pay attention to a couple of patterns here. We have this chord is equal to this chord. So this chord right here and this chord right there, they're equal to each other. And one of the rules is that if you have a central or inscribed angles, this is a central angle now. So this angle right here, 60 degrees, the opposite of this chord, and this chord is the same size as that chord. That means that these two angles, angle 60 and angle 3, must equal to each other. So what does that mean? And angle 3 means is that 60 degrees. Okay, so very simple. Angles that are opposite equal chords, they are equal to each other as well. Let's go to angle 1. Angle 1 is very easy, and that comes right from the semicircle theorem, or you can just say this is an inscribed angle opposite of this big central angle and 180 degrees, and the central angle which shares the same chord, and this chord is now the diameter of this circle. Of the central angle, it's half the measure of the central angle. And central angle in here, the big one right here, that's 180 degrees. Angle on a line is equal to 180. Must be 90 degrees. Excellent. This tick mark right there that we have is the same as this one and the same as that one. And if the central angle on these ones are 60 degrees, right? We have 60 degrees here, and angle 3 is also 60. And this small angle there, opposite the same chord or equal chord as those ones, inscribed angle opposite the chords that are equal to the central angle, they measure half the central angle. That means part of his angle 2, not quite angle 2, but part of his angle 2 is 30 degrees. Okay, that's part of it. Now we need to find the last part, which is right here. And then what we will do, we will add that part to the 30 degrees and we get the total angle. To get this angle right here, the first thing we need to do is that we need to pay attention to that this angle 3 we know is 60 degrees. And if that is 60 degrees, and we know that this part, this side and this side of this triangle, these two legs, they're equal to each other, because why are they equal to each other again? To both of them are radii of the same circle. And if that's the case, this is an isosceles triangle, that means this angle right here must equal to that angle. But in fact, if this is 60 degrees, the angle 3 is 60 degrees, then the remaining value will end up being 180 degrees, because the sum of the all interior angle of a triangle, angles of interior triangle must equal to 180. But we subtract away from 60 degrees of angle 3, we're going to get 120 degrees left. But these two angles are exactly the same. So if they are the same, we are going to basically take 120 divided by 2, and we get 60 degrees. Now it turns out that we started saying an isosceles triangle, but in fact they are equilateral triangles. All right, angle 2. Now what is angle 2? Angle 2 is equal to 30 plus 60 degrees, which is equal to 90 degrees. Oh, excellent. So which is equal to angle 1. All right, that is it.